Welcome. This session is titled Extreme Heat and Aging Exchange, and that's also the name of the website that we are launching today, which is part of a larger research initiative at Cornell Tech. This piece of it is really centered around creating a forum for people to share data for climate adaptation research and action. Just to give you an idea of what we're going to be covering, um, first, I just want to provide some context on the Cornell Initiative on Aging and Adaptation to Extreme Heat, which is getting underway this year. We'll have some short remarks from two of our researchers who are leading some of the work on public health and individual health in that initiative. Then I will share the website, which is really the tool for collaboration. That's really the purpose of this session, is to seed the network that we want to build around that resource. And then we'll have an open discussion with lots of information about how to get involved. And we want to hear from you about the kinds of data that you're looking for, the kinds of data that you might have to share, and the research questions and interventions that you're working on around this huge problem. Here's a semicode to grab these slides. I'll show that again at the end. So this larger initiative, of which this exchange is just one project, is a collaboration between Cornell Tech, Weill Cornell Medicine, and the Public Health Program, which is actually up in Ithaca. But it's very much focused on New York City. And basically the idea is to leverage the resources of the university to do research, develop interventions and test those interventions to try to reduce the risks experienced by older adults from extreme heat in urban areas. There's really kind of a perfect storm of challenges coming together that are creating a lot of potential for harm. The US population is aging very, very rapidly. Older adults are much more vulnerable to the health hazards of extreme weather that's caused by climate change, just through physiology, through other social determinants of health. They tend to, not have as good housing, not have the right support networks in order to adapt. And so people over age 65 nationally account for more heat-related hospitalizations than any other group. They're really the ones that we need to focus on as temperatures rise. For New York City in particular, a large humid city along the coast, urban heat island effects elevate those risks. And the more I learn about urban heat island effects, the more scared I become. But New York City, we can see overnight highs of more than 7 degrees above the surrounding regions. And it's really those overnight highs versus the daytime highs that cause problems, because people's bodies don't get a chance to recover from the daytime heat. Big picture, the way we're coming at this problem is really to recognize that there's kind of 3 big systems in cities that protect the well-being of older adults from extreme heat. Obviously, the healthcare system delivers medical care when people are already sick. The public health system tries to prevent people from getting sick by helping them avoid exposure and get away from risks and hazards. And then the built environment really shapes kind of what the baseline is over time. How much of a heat island effect is in place, where cooling centers might be available, and other ways that people can adapt. And the exclamation marks in here are sort of to represent that within each of these systems, responses are being delivered to the problem of extreme heat. Those systems are mobilizing, making plans, making investments. And health tech, which is something that we focus on at Cornell Tech, and urban tech as well, are already delivering innovations within these systems. So, in healthcare, we're getting better diagnostics and treatments for people with heat exposure. In public health, better predictions and emergency alerts to give people, this sort of warning that they get of a hurricane to move out of harm's way. And in the built environment, we're just getting much smarter about understanding where we need to make interventions that will pay off in the future to reduce these urban heat islands. But those responses tend to be a little bit siloed. These systems are big. They're moving as fast as they can, but they're most effective when they kind of stay within their boundaries. But we know that taking a more strategic approach will be more effective. And in fact, there's even cases where what these systems are doing may be making it harder for each other. That's how poorly integrated they can be. So more integration across these silos is needed. And we also see an opportunity for technology to do that. So if you look at kind of the intersection of healthcare and public health, what if alerts could be more personalized based on people's physiology or even their individual medical history, so that those warnings can be really targeted and really precise. Or if you look at the intersection of all three systems, can we put cooling centers in places where they're actually going to be available and equipped for people who may be coming out of emergency rooms during a really severe heat emergency, but they can't go home because that's the place that made them sick in the first place. So I think this is a really long-term perspective. It's one that really highlights the challenges, but also highlights, that we do have these new tools and new ways of working that can allow us to overcome those challenges. I think just, to sort of like put the dot on this of why thinking across these silos is so important. Last summer, there was a study published based on some work at Georgia Tech and Arizona State that was trying to understand and model out, what would happen if a big heat wave hit a city like Phoenix at the same time as a blackout. And these things actually are connected because the power grid is coming under increasing strain during heat waves, as well as the temperatures are higher and the power loads are higher. And, the long and short of it was that, and this is a pretty terrifying projection, it's actually one case where I hope the science is totally wrong, but they were saying that a 5-day heat wave and blackout in Phoenix would send half the population of the city to the emergency room. Of course, the city only has 3,000 emergency room beds, so we really need to mobilize every tool we have available to avoid that happening. So this is why we launched this initiative across the university this year. We have a number of projects that are getting started. And really what we're trying to do here is establish kind of a knowledge base that we hope to scale out from, to build out a network of folks in every sector, in universities, in civil society, in government, and in industry. And we have 3 projects that we're launching this year. The first is about informing response to extreme heat events via granular urban data. The second is looking at extreme heat and medical needs among older adults. And the third is essentially creating a piece of infrastructure for sharing data and models and other resources, which we'll get to in a second. But first, I'd like to give my colleagues an opportunity to come and make some remarks about the scientific research that's really at the core of this initiative. Nikhil, are you here? Do you want to unmute yourself?
Yes, I'm just going to maybe briefly talk about a direction. Me and then 2 other faculty, Jen Meredith, who's in public health, and Emma Pearson, who's in computer science at Cornell, are sort of scoping out and starting. And really, the idea behind sort of this direction is, as Anthony sort of intimated a few slides ago, an extremely hard part of sort of this challenge is just like the lack of data that a lot of decision makers have on the ground, and then also just like the distributed nature of all of these like really cool tools that various people have built in very particular contexts. And so that's part of the motivation for just Anthony building out collecting everything that's out there and sort of creating this data repository. And sort of the purpose of this project is to try to figure out, okay, in the best case scenario of having extremely granular good data, sort of, joining in public health data and sort of things from hospitals. And of course, in New York, we have really great data on heat islands and temperature measurements and sort of forecasts and all of these sort of things. Sort of what could one do with that data to make better decisions? So both in sort of the long term of like, here's where the city, from predictions on, heat islands and temperature, very microclimates and social determinants of health, here are where the city most needs cooling centers that maybe it doesn't have right now. And then sort of both real time, and then of course, real time and heat action plans, is there anything sort of that data provides on top of like common sense decision making that, a lot of agencies are already doing? So this project is to try to explore some of these questions in the context of an hopefully extremely data-rich New York.
Great, thank you. And Deborah, do you want to come off and say a word about your project?
Yes, happy to. And importantly, this is a project with Arnab Ghosh, who's a medical doctor, which I am not. I've been working in the space of digital health for long enough that I occasionally can fake it. But to be certain, this is the kind of work that you always want to do with somebody with deep domain expertise. And Arnab is certainly that person. And so what we're doing, there are things you could do at a public health level to try to inform planning, placement of cooling centers, understanding the scope of the problem and the size of the problem. And an important piece to it is to understand the actual effect of these extreme heat instances on older adults in particular, understanding the effect that it has on a general population with average comorbidities by the time meaning other conditions they have by the time they enter that category, and also to understand how it's not just the conditions they have. You see at the top of this graphic, it's also maybe the medications that they're taking because of those conditions, which then make them vulnerable in different ways to heat. So we're setting out with not the most open of all data that's a little trickier to get to, trying to go beyond mortality data, which is generally publicly available, to understand morbidity data. Who is getting ill, who needs treatment, who generally often not hospitalized, but comes to the ER for help, or who suffers at home and then has longer term consequences for their state of health because they were subject to too much excessive heat, didn't have interventions such as reducing a medication or being particularly careful about hydration and those situations. So Dr. Ghosh is starting with analyses of the data to look what we can see from the data about where the high morbidities are. And there's been work going on around the country and around the world to some extent on this problem, but there's clearly a lot that we can contribute. So to understand where the needs are based on comorbidities, medications, as well as very much so living conditions. And then to begin to think about doing some prospective studies. We hope that what we learn this year will let us begin to do some studies of actual individuals in their actual homes during the course of the extreme heat events that we will absolutely experience, unfortunately. And it's very important. You can't treat a city as a whole, certainly not a city as dense and diverse as New York City. And it's very important to recognize that a lot of the places that have the worst heat conditions indoors are also in areas that are generally under-resourced, and we really need to figure out how to bring together the urban tech, as Anthony was saying, along with the health tech to bring the right interventions, some of which have to do with some form of indoor cooling or really helping people get to those cooling centers under the worst of days. A couple other things I wanted to mention is that Anthony mentioned how important nighttime is. And nighttime is important not only because it's no relief from the heat, it also affects sleep. And sleep then has downstream impact on heart health in particular, but other things as well. Something I forgot to mention on the medication side is that this is not only medications that might have to do with with cardiac conditions, things like diuretics that cause you to release extra fluid that you might have building up, which puts added pressure on the heart. But when you have extreme heat events, diuretics could leave individuals severely dehydrated. And there are also medications that people take for various behavioral health conditions that also make individuals heat sensitive. And those are individuals of any age. But these things sort of accumulate. You're taking these medications on top of generally having an older body, and older bodies have more trouble dissipating heat. So in addition to trying to find out what needs to be known, who needs to be intervened with, how might we develop guidelines for adjusting medication, all those things, we need to somehow feasibly be able to intervene. And that's where telemedicine and various digital health tools come in. They come in because they'll help us do the research, the prospective studies, to see how individuals are doing through their wearables, through in-home temperature and air quality sensors. But then beyond the research, they will help us actually turn this into practice so that we can hopefully be able to do affordable interventions across the city and across the population in need. So I think that's it, Anthony.
Great. Thank you, Deborah. Yeah, I mean, personally, for me as an urban planner, this project has been fascinating because I thought we had all the answers to urban heat, and it turns out we really don't have any idea what's going on. People are being treated, they're given medications, and that turns out to be as important, if not more important, a part of understanding how they're going to fare as conditions worsen. So the third piece of what we're doing, and this is really something that we kind of realized that we needed to do for ourselves, but that there were, many, many others out there studying, intervening, trying to understand this problem and how to do something about it, and that data and models and resources of many different kinds, visualization tools, research papers, policy reports, that there was a need to kind of pull all of that together and pool it and make it available to the community. And then that also would be a way for us to discover each other. And so the part that I'm leading is what we're calling a data and model collaborative, the Extreme Heat and Aging Exchange. This is a website. It's up now if you want to go check it out at extremeheat.us. And we really think of this as a forum for researchers, policymakers, advocates to find and share whatever they may need. Right now, we have about 40 open data sets. In the spirit of Open Data Week, we decided to start there. And also a number of visualization tools that have been provided by government agencies, researchers. Some of those actually share the underlying data, some of them haven't yet, and a whole bunch of other resources. And the idea here is to try to start a conversation, which we really want to start today, around, what data do folks need that are trying to understand and intervene in this problem? What data might they have to share? As Deborah mentioned, a lot of the relevant data is quite sensitive and quite tightly controlled. And I think more than a lot of kind of problem areas, we have a wide variety of sort of data openness in this space. And so, as this evolves, it may become a place where the existence of data sets is advertised, but not necessarily shared. But it's a place where we can start a conversation or start a process of figuring out, who we can share it with and how. So our intention is to respond to that, as needs arise over time. But really, use this as a catalog, a place where people can find resources. So just to give you kind of like some visuals of what some of that looks like and some of the data, the syndromic surveillance data provided by the Department of Health and Mental Hygiene is one that has been used by a number of different researchers to try to understand, how heat is translating into medical conditions that need to be addressed. There's lots of stuff coming out of the federal government right now. And this is this future projections of extreme heat from the Global Change Research Program is kind of a baseline that a lot of folks are going to be using, both for thinking about future scenarios and projections that they might be studying or planning themselves into. Just to kind of orient you on like how each of these cards, what it contains, it's basically a title, the data or resource provider, a link out, and then sort of a little bit of a tooltip about what you'll find when you get there. Again, because we're cataloging more than just data sets here, but also things that let you interact with data, query tools, or things that let you look at data, visualization tools. We'll also, I think we have a couple that link to other catalogs, which we thought was probably a more effective way now than actually like pulling in every entry from those catalogs, but we may do that eventually. And then increasingly, we're putting like really what we think are like seminal studies and findings from the research literature in here as well. And then where we can, we're trying to give you a little bit of insight into how frequent or how recent the data is, how timely and frequently updated it is, which of these silos it corresponds to, and then, kind of what the geography is. And that's also going to be a work in progress as we try to understand what people's needs are for coding this. There's also, when you go to the site, a whole bunch of filter tools on the right that you can use. We don't have search yet. That's coming very soon. It's just, it was kind of the last on our MVP list of features and wasn't ready in time, but you can drill down pretty quickly with these filters that allow you, to sort and slice the list quite quickly. But that's basically it. What I was hoping that we could do now, I was really excited to see folks introduce themselves. I expected there would be a huge diversity of people here in the kinds of things that are, drawing you to this topic, the kinds of work you're doing. But I think these are the questions that we really want to start to engage a bigger community around this exchange. Is this useful? Is the catalog something that you will turn to? And if not, what else should we be doing? Can we be going out and looking for data sets? What knowledge gaps are you facing? And how can we help fill it? Are there other open data resources out there that we should be scanning and cataloging as well? And then, that's sort of on the data supply side, but on the data demand side, what kind of data is not being widely circulated or advertised, but is relevant, and who has it? And once we identify who has it, how do we incentivize them to contribute? Obviously, that's a more complicated discussion, but I think it's where we need to go eventually. And then we can talk about getting involved. If you go to the extremeheat.us website, you'll see at the bottom, there's a bunch of different links. The easiest one is to just sign up for our mailing list, and we will keep you up to date on additions to the catalog, on other outputs from the research and other events. There's also a link to contact us if you want to get more involved in helping us design this project going forward and governing it. There's one version of this that I think has many different partners who are actively involved in curating and contributing to it, and taking an active role in expanding the network as well. And we're certainly interested in talking to folks about that. And then you can just suggest a data set, either contribute or, if there's something that you want, we would love to know that. But why don't I stop there? And I think you can raise your hand if you have something to say. And we would love to hear from you about the work that you're doing, the data that you're using, the data that you need, or the data that you want to create. But thanks everybody for coming, and I hope you find this site useful. Looks like somebody tried to use the QR code and it didn't work, which I apologize for. So I will put the URL for the exchange up on the website here, and that should work.
Hi all, thanks for having this. My name is Lucy Cummings and I work at New York Disaster Interfaith Services. And my question is about disasters and the impact of extreme heat in terms of deaths, mortalities that are being reported by FEMA or whoever else. And I'm not sure if anyone's working on the need to include extreme heat as a category of disaster declaration. Thank you.
Yeah, that is a great question. I don't think anyone on our team is, but if there are, other data sets or other kinds of resources that are related to that that topic, that would be something that we could certainly share through the exchange.
Hello, everyone. My name is Caleb Smith. I'm the resilience coordinator at WEACT. In terms of another data set that would be of interest, one thing that has been sort of an area where I'm not sure where to look to get more information on this is sort of building electrical capacity, in that we have a lot of planning to do with more demand on the energy grid from air conditioning and other forms of cooling. It's hard to know exactly how many buildings have a limited electrical capacity to run cooling devices at the scale necessary to give people like thermal relief. So that's a data set that I find myself running up against the lack of often.
Is that something that you're anticipating as a problem, or is it already like we have buildings where breakers are being tripped because people are putting air conditioners in, or?
I mean, I'm not sure. Like, I don't know the scale of who this is impacting yet.
Yeah. Thanks. That's a great suggestion.
Hi, everyone. I'm Zachary. I work on the New York City Open Data Program. And one just general comment is that I don't know how many people are aware, but one, New York City has a law that requires agencies to share the information that is defined as public data. And two, if you're looking for information and you don't see it published already, you can request it. And essentially the three outcomes are one, if it exists already and it's published on open data, it'll be sent to you. Two, that information will be published at some future date and the date will be shared. Or three, it'll be explained like this doesn't exist. We don't maintain this. So if there is information that you're looking for, there's a bunch of ways to get it, but one of them specifically in New York is that request process. And I'll put a link in the chat.
Zachary, I had a question for you. Well, so I just wanted to ask, because I know the city has been doing a really great job putting out, I guess it's the mayor's office sustainability, and I can't remember, like dashboards of sort of like data around these different topics. Like, what is the relationship between the data that goes out through the open data portal and the data that goes out through some of those more sort of policy area dashboards?
Yeah, so in some cases there are dashboards where the underlying granular information can't be shared, but aggregate information can be shared in a dashboard. But otherwise, the summary information and in many other cases where it's not like quite so, there's not like a concern about privacy, even the granular information can be shared and in fact is required to be shared. So again, if you're seeing information in a dashboard, you don't see an equivalent data set, I think that's a great candidate for a request. And again, I'll put that URL in the chat.
Great, thank you.
we encourage agencies as they're thinking about like, I'm going to make a new dashboard, to also do all of that work and thinking about the equivalent corresponding data set up front. So that way they don't have to get these requests and they're doing that work at the start.
On the individual level, it's two steps. There's a lot of data that just doesn't exist, such as the previous question about how many, we know data about brownouts in the city, but we don't have at the granularity of individual buildings. We also just don't have the granularity of that extreme heat exposure within dwellings, and nor do we have the effect on individuals, because a lot of it just isn't captured. So getting to open data is multiple steps. I think first we don't need every dwelling, but we need enough and of different types that we begin to have the right kind of model to know where the real stress points are. We need to develop those models, and sometimes we can never share that granular data, but we can share some aggregated data. And when it comes to clinical interventions, you share better models and guidelines for how you should treat somebody. What is the message that should go out on somebody's health portal if they're on these 3 medications and as a heat wave is anticipated? Those sorts of things. So there's a lot that we are hoping to do that includes open data in getting to those models. And the end result is not always highly granular data that gets shared, just because of the privacy implications, both of what's going on in your home and your personal health records. I did notice that somebody who had their hand up.
I just had a question, and I think you just spoke to it, which was about wanting just population data by age at a granular level, because in the past I've done some GIS mapping, and it really helped to help us tailor our outreach. If we knew where there were clusters, like if there were NORCs, or if there were clusters of people, say 65 and over, where we could conduct outreach. So where we would go to them versus them coming to us. And so anyway, yeah, that's the reason why I was asking, is just to be able to tailor any kind of outreach to that population.
Yeah, I mean, maybe that'd be a question for Zachary. Like, is the open data portal like sharing extremely granular population data net right now, or do we go to the census for that, or what's the authoritative source for that?
I would definitely go to the census for that. There are some, and this is where like some agencies have interpretations of census data, and people from the health department have a better sense of that in this particular context than I would. But typically, yes, I would go to the census for that.
SJS 96. You're on.
Oh, hi. Sorry, Schmidt, Cornell City Planning up in Ithaca. I guess along the lines of that last comment about population data, other sort of environmental covariates, whether that be, I mean, obviously you can get the parks data set, but any sort of other open space, tree data sets, other environmental data sets, that potentially, from at least a research perspective, could be very interesting to look at the relationship with heat, and also land use data sets, density, zoning, things like that, and other ways that just to examine at a micro level how the built environment affects sort of small scale variation in urban heat. I think potentially would be a useful addition to the database.
Great. Yeah, no, there's a bunch of we actually, Cornell Tech has been looking at trees a lot using the citywide LiDAR scan, and there's some derivative data products from that work that we can put in the catalog. We've basically isolated individual tree canopies from the entire citywide LiDAR scan, which you can use to model stuff at the individual tree level. So that's an open data product we're going to push out of that. But yeah, we can also do the scan and pull together all that relevant information, because it's all out there. Thanks to New York City Open Data. I think maybe we will just thank everyone for coming. Again, thank New York City Open Data, thank Beta NYC, and have a great night. Thank you.